Hi, today we're going to be taking a look at this Sinclair digital multimeter. And I saw this on eBay for spares or repair. I'll just bring the listing up. And I paid just under £23 for it. So in the listing it says that it's already disassembled, so we don't really have to disassemble it. So let's have a look. It comes with the adapter here. Let's have a look inside of it. And it looks in a bit of a state, to be quite honest with you. Let's just zoom down a bit and we'll have a look. You can see some nice bubble LED displays there. Might get those under the microscope later, so we can have a bit closer look at those. And I've got a load of wires off everywhere. It looks like this foam stuff here is rapidly decomposing everywhere. So I think the first thing I'm going to have to do is try and work out where these wires go. And then we'll see if it's got any life in it. So I'm not sure. I've got a ground wire there. I'm not sure what the grey wire is here. So I'm going to have those two go over to the switch because they're kind of got a bit more length on them. And then we've got 3 wires go to here. I don't know what this red wire's for. I'm just going to have a look online. I'm just curious to see if there's any photographs of any of these online, just to see if I can work out where the wires go. Right, back in a moment. So I managed to find online somebody doing a teardown of one of these, and I can see where all the wires go now, or just about. I'll just bring that picture up so you can have a quick look. So let's get the soldering iron out and we'll start soldering some wires up. So it looks like this grey wire goes to this top terminal here. It looks like we've got a pink and red go over to here. I might need to put a bit of fresh solder on that. It looks a bit not the best. I guess there'll be more wrong with this. I don't know why somebody just took all the wires off and taken it apart. So I guess there's other issues as well. Alright, so looks like there's a pink wire and goes to this bottom terminal. I'll just turn that around so it's easier to get into. It's not the easiest to get into, this one. I think that's on just. And then the red wire went to this top terminal. Again, I think it needs a bit of fresh solder on that one. So on the diagram that I found online, there's no red wire here, so I'm not sure what that one's for. Let's put this soldering iron away a sec. And I'll just grab a 9-volt battery. Right, where's the on off button? Oh, we've got something on the display. We've got 2 lines, a minus sign, and then 3 zeros. So at least the LED display is working. Oh, the wires just came off there. Right, so I need to solder that back on. I'm just going to snip the end of it off. Right, let's solder that back up. And we've got the display back on, so. Right, I'm just going to switch that off a second. Let's just try soldering, because somebody's disconnected all of the connections here. So let's see if I can find a resistor just to solder on across here. And we'll see if it'll read a resistance reading. Right, so let's go and grab a resistor. Right, back with a resistor. And it's a 470 ohm one. So we'll just solder this across the pins. So common and that one, so it'll be these 2 end pins here. Let's just solder that on. and then we'll switch it on and see if we get any reading. Right, got that soldered on. I want it to be on resistance. Let's just try the different ranges, see if that does anything. Right, so it just seems to be permanently stuck on the 3 zeros with the 2 lines, and that's it. Right, so where do we go now then? Let's just zoom down again. Some numbers on some chips here. I'll just spin that round. So we've got an AY53507. So that looks like possibly some kind of display driver. And then we've got an LM3900N or 3900. We've got a CA3130. So I'm not sure whether those two are op amps. And a 4007. I can't remember what one of those is either. It looks like we've got a few diodes and transistors and capacitors as well. So we've got a little resistor block down here. That may be for selecting the different ranges. We've got a 10 ohm resistor, a couple of capacitors and a diode. So it looks like the resistance measurement comes in on here. Now I think there is a schematic on that site that I found. So let's just go and have a look at the schematic, see if we can see anything on the schematic that might be useful. I'll just pull that up on the screen there. So this is the schematic for it. And there's the display down there. Well, it doesn't actually tell you which IC is which, it just says IC2, IC3. And I couldn't see anything marked on the board. And also it doesn't give you any values of the resistors here as well. One of the IC seems to have a number on there, this 3130, which is an op amp. And it looks like this is where the leads connect down here. So it looks like the resistance one goes to this resistor network through the switch and then into the input of this op amp. It looks like we've got a couple of capacitors here. So I think I'll start by checking those capacitors. And it looks like the output of the op amp goes along and goes to pin 5 on this IC here, which looks like the display driver. Right, at least I've got something to look at now. Right, let's just zoom back out again. So it comes to this op amp just here, which is here. Now we'll just check back to see which pin it was. So the signal comes in on pin 3. So let's just zoom down a little bit more. So pin 3 is that one there. Let's find something to point with a sec. So pin 3 is that one there. It seems to come through to here. Looks like it goes through that resistor. Yeah, and that must be the switch where it selects. Oh yeah, there it is there, yeah. So it goes through to here, through that switch, and then into this op amp. Right, I think I'll just start testing some stuff with the meter and we'll see what's what. Get the test meter out. Let's just start checking some things. Right, so I've got a capacitor there and a capacitor here. So I wonder if it's worth checking those with the capacitance meter that Jeremy kindly sent me. The ESR 70 gold. Right, I'll just go grab that. I'm back with the ESR 70 gold. So we've got a capacitor just here. Looks like 4.7 at 10 volt. Oh, 47, sorry. Let's see what this one is. A 16 volt, 22 microfarad. Let's just try that one. It doesn't like that. Actually doesn't look too bad. We've got a 10 ohm resistor and a diode. Let's check those. But it seems to be something on the input side, I think. That seems okay. Let's see if that resistor's okay. And it is. Right, what else we got on here? Got some more diodes. Let's just try those. Seems okay. Seems okay. So we've got another two down there, but I can't get the leads on them. I think one of them's... One of them seems to be about here somewhere. Not there. Oh, I seem to have a... That's a little coil or something. Right, looks like we've got a diode there, so that one measures alright. Another one there, that one seems to measure okay there. I'll just got it on, there we go. Right, so those diodes are alright as well. What else? We've got 1, 2, 4 transistors. Let's see if we can check those. This is another transistor. Oh, well, they're the display driver transistor, so it's not going to be any of those. But I did see some transistors around about here that seem to be connected to op amps and things, so let's see if I can try some of those. That one's alright. That one's okay. Another one here. Yeah, that one's alright. I've got one down here. Yeah, that one seems okay as well. So the diodes and the transistors seem okay. Let's see if I can find a data sheet for this chip here. So I managed to find the data sheet for the IC, and it's a 3.5 digit digital voltmeter, and it's automatic polarity detection over range indication. And the weird thing is it takes a -15 supply, which is a bit unusual. It looks like it takes a clock input, so it might be worth checking that on the scope to see that we're actually getting a clock there on pin 14. And pin number 5 is the comparator input, which I guess is the signal into it. Let's just flick back to the schematic here. And pin 5 goes along here and goes to that 3130 op amp on the output of it. Right. So there's a block diagram of it. Right, let's see if we get a clock on pin 14 and let's see what the voltage is on pin 5. I think that's going to be the best thing to do. Right, I've got the scope hooked up and we're supposed to have a clock pulse on pin 14. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Should be this one here. And it looks like we've got something there. Let's try adjusting this scale. And we'll just adjust the time base a bit. There we go. And it's about 10 kilohertz. So we've got clock there. That's the other thing I was going to do. I was going to check the voltage on pin 5, wasn't I? Right. So if we just go on to ground, let's use this here. And pin 5. It's a bit awkward to get into. That's the angle that I'm at. 2, 3, 4, 5. Tell us if I'm on a volts DC. So I've got 8.78. So on the data sheet it says comparator input, and it says logic level 0 corresponds to a negative input signal and logic level 1 corresponds to a positive input signal. So I don't quite understand that, because I would have thought the comparator input would have been the sort of signal input. So I'm not too sure on that. However, I did find the actual manual for the meter, and what it says here is it says overload, with the exception of the times 1000 volts DC, all ranges can be used up to the displayed value. When this is exceeded, the display will show, and it's got an equal sign with 000, or sort of 3 lines and then 000. So to me, I think it says positive overload always gives flashing bars. A small negative overload will also give flashing bars with the negative symbol, but a larger one will give fixed bars. And we've got fixed bars on here, so I guess the meter's getting too much power on that input and it's telling whether there's an overload. So I think that's what the problem is. But now we're going to try and find out what the cause of it is. So I thought I'd bring the microscope in just to make it a bit easier to see what's going on. And I thought we'd have a look at this display here. Let's see if I can get that to focus in a bit better. There we go. It looks like actually gold, this. You can actually see some gold lettering up here. And a bit of gold down here as well. And it looks like there's some empty positions. For more dies, so you've got more digits on the display. Right, I'll just switch this off a second. Interesting enough, it showed a 1 there briefly. Right, I'll just switch that off a moment. So I'm just wondering if it's something like one of these op amps has failed. So the signal seems to come in on this op amp here. Let's see if I can get those wires just out of the way for the moment. Let's refocus this in. Right, let's see if I can find the pin out on this op amp. So pins 2 and 3 are the input and pin 6 is the output. So let's measure the voltage. I'll just switch it back on. Let's measure the voltage between pins 2 and 3. And we've got 8 volts going to there. I don't think that's right. Because that should be, this is switched on fully then, as far as I understand. I'll just go into ground here and I'll just measure the output. Which is pin, is it pin 6? And we've got 8.55 volts there. So it looks like there's something before this op amp. Right, I'm just going to have a look back at the circuit diagram just to see where the signals come in to this op amp. This op amp here, looks like one pin is kind of tied to ground, which is pin 3, and then it also goes to the input. But pin 2 comes from another op amp, which is pin 9 on this other IC, and that's a quarter of it. So there must be 4 op amps. Yeah, IC1, there's another op amp. I don't know what else uses IC1. It's down here as well. And that also seems to go to the ohms input switch. So I'm just wondering whether somebody has measured voltage when it's been connected on ohms or something like that. And maybe blew this op amp up. IC1. Right, let's see if we can test anything on this op amp here. IC1. Right, so IC1, I guess must be this LM3900. I'm just going to switch this meter off a second. Now, I did have a look online how to actually test op amps, because I haven't really used a lot of op amps. I normally just use things like microcontrollers and whatever. I've tended not to have made stuff that's used op amps before. So, but I did find somewhere where it did say if you put your red probe on the negative, and if you go into diode check, a quick and easy way to test op amps is you should have a diode reading on the input pins. Oh, we'll get nothing on that one. We do on that one. We do on that one. We do on that one. We've got nothing on that one. We do on that one. Let's just check some of these other ones. I don't seem to have anything on that one. Right, I'm just going to get a pin out up of this IC. Right, so I've got the pin out of the IC here, and pin number 1 is the first op amp non-inverting input. And that one seems okay. So the inverting input on op amp number 1 is pin 6. And that one's open circuit. So op amp number 2, non-inverting input is this one. I'm not getting any reading on there. And that's the inverting input. The next pin down's output. And output there. So let's try op amp number 3. And I'm not getting a reading on op amp number 3 non-inverting input, but we are on op amp number 4 non-inverting input. And the next pin down is pin 4 inverting input, and this pin down here should be 3 non-inverting input. So there's definitely something going on with that op amp. There's definitely some pins. It looks like it's going to be a bit of a struggle to remove this because it's got soldered. It's soldered on the top as well. So I don't know whether to try and put some low melt solder on this to try and get this off. I wasn't sure if that was a crack or something there, or whether it's just a mark. Might have to take that capacitor out just to allow a bit more access into that chip here. Right, at least I think we've got something now that doesn't seem right. So first thing I'm going to do is remove this capacitor. Which I think is that pin there and that pin there. Might actually be that pin there and that pin there. Right, so just get that out of the way. I'm going to use some solder wick to try and get rid of some of this solder on the top there now. I'm just going to add a little bit of flux, I think. Right, let's flip the board over. Just going to snip some more of this solder wick off. Just get a fresh part. I might need to use any low melt solder on this. I think I might actually do. Let's load a little bit on that one. Actually, some on that one as well. Well, that's the old chip removed. I don't think we've caused any damage to anything, so that's good. Right, I'm just going to give that a bit of a clean up on the back with some IPA, or isopropyl alcohol. I'm just going to use a toothbrush and then use a cotton bud just to clean up. Right, I'm just curious to see what it does now if I plug it in and switch it on. So I'll just connect the battery up. I've got a minus 0.000 now. So that's definitely different. Right, so I'll order a replacement chip, and when that comes we'll fit it and see if that fixes the problem. It's been a few days and the new part has arrived. So I think what I'm going to do, I'm going to compare this chip, which is the original one, with the new chip. So let's just get this out. I'll just zoom down a bit. I'll just go on to diode check. So this is the original chip here, so let's get on there. Right, let's try and keep my finger on it. Right, so we're not getting anything on that pin. So we're not getting anything on the first two pins. I'll just try and get my probe on a bit better. Right, so nothing on the first two pins, and we get a diode reading on all of the rest. Let's just try this side. So the second pin down and the one next to the end here, we're not getting any readings on. Let's just compare to this chip, which is the new one. Yeah, we're getting readings on all of those. So that definitely seems to be faulty. Right, let's install it. We'll put this capacitor back in and then we'll see if that cures the problem, or if there's any other problems. Let's put that old chip out of the way. And I don't know whether to bring the microscope back in again for this. It might just make it a bit easier, because it's quite small with, even though it doesn't look that small, it's quite small, especially when my eyes aren't the best these days. So I just find it easier to use the microscope. Right, I'll get the microscope set up. Right, the new chip's in place. So I need to solder up these two top connections first. So let's get the iron on it. Right, that's them two done. Right, let's flip it over and we'll do the ones on the back. And this is the TOMLOV 4K Max, 4K-AF Max, sorry, autofocus one that I'm using. And if you've got old eyes like me, it doesn't half make a difference. Right, we need to pop that capacitor back in and then just resolder these two connections. I might do those first, just before I forget. And I'm going to remove this wire. I think somebody must have put this on for testing. So I think when the previous owner broke it or whatever, I think he must have been trying to figure out what the problem was. Right, let's pop this capacitor back in. I'll just try and solder that up. Let's add a little bit more solder to that. I don't know what that pin is, a hole. Right, let's get the microscope out of the way then. Right, let's pop the battery in and see what it does now. Ooh, I've got a reading there now. .21. Well, I'll just check that we're on ohms. Ah, the end one's diode check. So that's ×1. I've just got some bad contacts on here, so the reading seems to be bouncing around a little bit. Especially when I move this switch. So I might try a bit switch cleaner in this switch here just to see if that's going to sort that problem out. But it does appear to be doing a lot more than what it did. Right, I'll find some switch cleaner. Right, let's give this a squirt. Let's see if that's made any difference. Well, it's a 470 ohm resistor. I don't know if you can see the display there. And it was just measuring 470, but now it's bouncing all over the place. I mean, the switch cleaner I'm using is not supposed to be conductive. I just wonder if that's having an effect on it, because it did seem to be quite stable at first. Let's try it on there. Right, I'm going to leave this to dry out a little bit, because it's showing all kind of weird readings now. So I've just been having a little bit mess about with this, and if I go on to the voltage reading, I'll just move this along. It's still showing a reading there, but we've got to set 0 here, so let's try setting that to 0. Alright, and let's try going back onto ohms now. Looks better. Yeah, 470 ohms. Or point, I think it's 47, that's a bit hard to see, 48, which is close enough. So I think this is working now. So what I'm going to do, I'm going to solder this back into the case, and we'll try some different resistors. We'll connect some meter leads up, we'll try some different resistors, and then we'll try some voltages from the bench power supply just to see if that's all working correctly. Right, I'll switch it off for the moment, and I'll get this put back in the case and soldered up. Well, it looks like we might have fixed it. I'm going to solder wick these bits of solder off the bottom here and then solder it back onto the pins. So I think we might have fixed this one. And the first computer I ever had was a Sinclair Spectrum. that me parents bought us for Christmas one year when I was still at school, so you probably need to work out my age from that. How do these bend over? I thought they were through holes, but I guess not. They must just bend over. And this case in here, I think it's actually been a calculator case and that's just been modified or repurposed. Let's see if we can get these wires out of the way so that sits a bit better. I think it's supposed to be some plastic pegs that go into these holes to hold this motherboard down. Right, so I guess that goes like that. Let's try and solder these up now. Let's try this one first. I don't think I've got anything that I can poke in these just to hold the circuit board flat, but I don't think it really makes a difference. Now the only other thing that's missing off this is it's got no back, and I think the knob's missing off the front, but it might possibly be to 3D print one of those. I'll just connect this battery for the moment. Oh, so the back goes on. Oh, there's a bit broken there. That's a shame. Right, so that's how it goes together. I'll just pop something underneath the bottom of it so you can get a better view of the screen. We've got 3 lines there now. Ah, that just might be... Was that because of the adjustment? Well, it wasn't doing that before. Ah, I know what it is. It's because we haven't got anything connected. Right. I'm thinking it's flashing there saying there's a problem, but it's probably because we haven't got anything connected, where before I had the resistor soldered across. I was wondering what was going on there. Right, I'll get some meter lead probes. Right, so my meter lead probes won't fit because they've got this shroud on, and that won't fit in there. But I do have some of these type, which... Let's just try it on resistance again. And I'll just pop something underneath there just to lift it up a little bit. As the battery falls out. There we go. Right, now where did that resistor go? Ah, there it is. Now I don't know whether the 0 has any effect on this, because I did change it slightly. Right, that's set to 470. I don't know whether you should alter it on the higher scale first or not. Right, I'll get some other resistors, we'll try some other ones. Right, let's try a 2.2K. And see what that measures. Yep, close enough. And I think this is a 470K. Seems to be thinking about that one. I don't think that one's very accurate. It seems to be slowly going down there. Let's try it on the higher scale. I mean, I don't know how accurate this meter. Definitely doesn't seem very accurate on this scale. I'll probably not be using this as my main meter now, by the way. It's just more of just something, just a curiosity than anything else. Right, let's try it on some voltages. I'll connect the bench power supply up. Right, I'll set this to 5 volts. And I'll switch it on. doesn't look like that made any difference whatsoever. So it doesn't appear to be measuring voltage. I mean, I'm on 5 volts there and it's showing 1 point. Yeah, it's definitely something not right there. So we might not have fixed this. Right, looks like I might have to take it apart again. I thought we'd fix that there. I'm just going to have another look over the schematic, just to see if I can see where it measures the voltage from. Well, I've had a look at the schematic, and I've decided to change some capacitors. So I've changed this one. I've had that one out and measured it, and that one seems okay, but I've still got this one to do. So let's get this one out. I'm just going to clean up those holes with a bit of solder wick. And I've got a new one to go in. I lost the end of my solder there. Where's it gone? Now I'm just going to snip off these excess legs. Right, we shall give it a try. Right, I've got the meter hooked up to the bench power supply, so I'll just switch that on. And I've got it set to 5 volts. I'll just try a different scale there. There we go, 502. So let's just try turning the voltage up a little bit. Let's try 12 volts. There we go, 12.02. I'll just turn it down to just a little tiny bit out, 0.06 of a volt, so it's not too bad. Let's just try turning it up to 24 or something. Now this is flashing because we've gone over the voltage, but if I go to the next range up, I'll just get up to 24 there. So yeah, seems to be working. Excellent. Right, I'll get it popped back in the case then. Right, it's all back together, so let's give it a final test. So let's do resistance first, and this is a 2.2K resistor. So if we go on to here, which is K times 10, we've got 0.225, so if we times that by 10, it's 2.2K. So that's working. So let's try volts now. I'll flick that over to volts DC. And I've got a 9-volt battery here. And I'll just clip this one on to the negative. I'm on AC volts at the minute. So let's see, 10 volts there. So it might be a little bit out of calibration. Actually it's saying minus. I've probably got the leads on the wrong way, have I? No, I've got the plugs in the wrong way. That's better. Let's see what that comes up with now. 9.75. So it says 0.975, and if we times that by 10, it's 9.75. So that's also right, or thereabouts. Right, so I think we'll call this one a fixin'. Right then, if you enjoyed this video, please give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.